Kia ora everyone. Today we're going to have a look at electrical isolation and recommissioning. So this is a topic that we have talked about previously in class. We've done practical sessions where we've had a look at this and we've discussed it and practiced it a fair amount. It's a really important topic in the sense that, this is one of those critical safety things that we just must get right every single time. There really is no room for error when we're talking about an electrical isolation because our lives are literally on the line. I've said before to you guys, and I'll say it again, that you can get away with being a bad electrician, but if you don't do this critical safety stuff right, then you might die, or somebody else might die. So your skill as Sparky will be vastly different to somebody else. Everybody's going to be different. Some of us will become excellent Sparkies. Some of us might become terrible Sparkies. Regardless, this is something that we just cannot afford to get wrong ever. So let us have a look. Before we start, I will just say that in the test for this topic, there is a few things that are not covered in this slideshow. I was going to include them, but I thought actually it would be better for us to deal with those via our conference calls. So I'll talk through the slideshow, and then there'll be a few additional points that we'll need to cover off in that conference. So that means that you're going to need to be there. Otherwise, there's going to be in this stuff in the test that you just don't know, you won't have seen. Okay, so isolated. What does isolated mean? It means that an appliance or circuit has been deliberately disconnected from the electricity supply and precautions taken to prevent reconnection. So we're not just disconnecting power to an appliance or circuit, but we've done something to stop it from being turned back on. Switched off has a slightly different meaning. It means the electricity ceases to be supplied to the appliance but can be restored at any time. So the difference between isolated and switched off then means if I switch off a circuit breaker or a light switch or something like that, that's switched off. There's no electricity present in that circuit at that time. But if I only switch it off, then somebody could come and turn that back on easily, or I could turn that back on. So the important difference there is when we talk about isolation, then we've done something additional to just switch off, which in the vast majority of cases will be physically locking out that circuit like we have discussed before, but it might be other things as well. If there's no ability for us to lock something out, we might physically, after we've switched it off, disconnect the wires coming out of the circuit breaker that go to our circuit, so that even if it was switched back on, that circuit is no longer connected. We've physically taken it out. So that might be another way that we achieve isolation. So isolation of fixed wired appliance from the electricity supply. When we're talking about fixed wired appliances, we've discussed this before, something like a heated towel rail or anything that is permanently connected to the supply. So there's 4 things that we need to do to ensure that when isolating a fixed wired appliance for safety that we do. First one is identify the fuse or circuit breaker. So we need to find out which circuit breaker it is that we need to turn off. I've talked about some of my misadventures in identifying circuit breakers. There's a couple of ways that we could do this. If we can physically trace the cable, that's obviously always going to be the best way because I can physically follow it end to end. If you're working inside a building that is not brand new, as in we're not physically wiring it at that time, you're probably not going to be able to do that. So we could look at the identifying information on the switchboard. Sometimes it will tell us which circuits are on each circuit breaker or fuse, and so I should be able to go off that. Failing that, we're going to have to use trial and error. It's not ideal, but sometimes that's the only way. And I've discussed a few tricks on that before. If the switchboard's in a different room and you're trying to isolate a specific socket, if you can plug a radio or something in that makes noise, then as you flick the circuit breakers in the switchboard, you'll hear that radio turn off when you find the right one. But we can just do it by trial and error, by physically testing that socket, go to the switchboard, switch one off, come back, test the socket again, so on. We need to ensure there's no exposed terminals. We need to test our isolation is effective using the prove, test, prove method. Now I think we'll talk about prove, test, prove in a little bit. But briefly, that's checking that our meter works, testing the thing that I've isolated to prove that it's dead, and then testing that my meter works again. So proving my meter, test the circuit, prove the meter. And then we need to secure our isolation. So as I said before, that's generally with a lock. Physically lock that thing out so nobody can switch it back on. So securing that. And here is our prove, test, prove. So we prove the test instrument is operating correctly on a non-live source. So this is normally when we're testing for voltage, we're doing prove, test, prove. I'm going to go to a socket or some power source that I know is live. I could do it on the mains entry into the switchboard, whatever, but something I know is live, and I test that, and I should get 230 volts or 400 volts or whatever the voltage is there. That proves that my meter is working. I test my isolation, whatever that circuit or appliance is that I've isolated. I test there, and I'm going to test between every single terminal. So it would be phase to neutral, phase to earth, earth to neutral, to make sure there's nothing on any of those. If it's three phase, I've got to test all three phases. And again, I've discussed previously my own misadventures in failing to test every single phase and finding that one of them was switched off and two of them weren't. My bad. So we're going to test every phase, and then we need to prove our test instrument again, our meter again. We go back to same non-live source or a different one. It doesn't matter as long as it's something that we know is live, and we're testing that we're going to get a live voltage there. That proves that my meter is still working. We proved it at the start, but just in case something has gone wrong, I might have connected my meter incorrectly or something and blown a fuse in it. We prove after we've done the test that our meter is still working. That way we know that our test result was valid. As I said, this is generally when we're doing voltage. We're testing for voltage. We would look at doing the two prove, test, prove like that. But even that's the main one for safety. But I mean, if I'm testing for resistance or continuity, a good little prove, test, prove is I touch my meter leads together, and I should see a very, very low resistance, 0 ohms or pretty close to 0 ohms, just the resistance of the meter leads. And then I do my test, and then I touch them together again, and I know that meter is still working and testing resistance correctly. So tags. Danger tags are used where there is a possibility of personal danger through the supply being restored. Out of service tags where equipment is faulty or damaged, and using that equipment would cause damage or injury. So whenever we do an isolation and we lock it out, we're going to attach a danger tag to that. So nobody could switch that on and give me an electric shock. We would use an out of service tag if there is a faulty piece of equipment and we need to again isolate that and prevent people from switching it back on because the equipment is broken or hazardous or whatever. First, it is important to first check with the owner or supervisor of the area before turning off the main switch, as this could shut down essential services such as medical or computer equipment. So if you remember our practical book, it talks about the informing first. So we're just letting whoever is responsible for that area know what we're going to do. We particularly need to do this if we're going to be switching off circuit breakers using that trial and error method to figure out which one is the one I want, because I might switch off something that shouldn't be switched off. And you know, absolute worst case scenario, you might switch the whole main switch off and kill the whole installation just to make sure it's safe, and then obviously then we're going to switch off everything else. So we need to know what we're switching off before we do that, and we do that by asking the person who's in charge that it's okay for us to switch things off. Okay, so our disconnection procedure, we inform the person, we get permission. We identify the correct circuit breaker, as we said before, and there's various methods to do that, but somehow we must identify the correct one. We ensure that all the loads are switched off, so anything that's on that circuit, particularly again if it's computer equipment or something, we shut that down before we switch the power supply off. Equipment must be isolated from the supply before disconnection, so we're going to switch it off before we touch anything. And then we isolate, and the isolation must be verified by testing. So we switch it off, then we go and test the thing that we're going to work on, as we just said, prove, test, prove, to make sure that we have definitely switched that off. Testing for isolation, if we test for voltage using prove, test, prove, as I said before, we test between each phase and earth and test between each phase and neutral. If it's one phase, then it's just phase to earth, phase to neutral. If there's multiple phases, then we test every single one of those phases to both neutral and earth. That is to make sure that everything is dead. It can happen. It has happened to me. That, one phase was dead. I assumed, once I've tested it and found phase 1 was dead, I assumed everything was dead. I was wrong. I still had live voltage on phase 2 and 3, and for my foolishness and lazy testing, I received 1 electric shock. I won't do that again. Precautions to be taken when attaching a danger tag to an isolating switch. Where am I? There we go. Make sure the correct isolating switch is tagged. Make sure the switch is in the off position before it is tagged. Fasten the danger tag securely so it will not come off. Test to ensure that isolation has taken place. Appropriate details are entered on the tag. So most of that is just part of our isolation procedure. But points to note there, make sure we put our danger tag on so it doesn't come off. Most of your danger tags will have a hole in it that you can put your lock through, so at the same time you lock your isolation, you attach your tag to the lock. And we're at the bottom there, it says appropriate details entered on the tag. So we're going to write generally who we are, and your phone number is a good idea, and perhaps the date as well. So if anyone else is coming along, if they need to turn it back on, they can get in touch with you. And it's far less likely that someone will remove a tag when they shouldn't if they can see contact details on there, because they'll go, I'll just ring the guy. If we still find voltage, now this is really important. I've seen people isolate something, test it, find that it's still live, and panic. They don't know what to do next. So if we do switch our circuit breaker or isolating switch off, and then we go back and do our prove, test, prove, and find that circuit's still live, here are the things that we need to check for. Have I switched off the wrong circuit protection, the wrong circuit breaker? Have I switched off the wrong isolating switch? We may have isolating switches there separately from the circuit breaker. That's fine if we isolate a switch rather than a circuit breaker, as long as we can lock it. But the same thing applies. If I've switched off an isolating switch and I've still got voltage, perhaps I've switched off the wrong one. The isolating switch might be damaged or faulty, so I might have physically switched it, but that's not done anything inside the switch. It might be broken. Or the neutral is being switched, which if you do all those other things and you're certain that you have isolated the correct thing and you're still finding voltage there, then we may have a switch in our neutral, which is a fairly serious problem that you're probably going to, at least while you're a trainee, you're going to need to get somebody else to help you with that, because something has gone terribly wrong. I have come across that a couple of times, so we were switching the neutral instead of the phase, and in one particular instance was where I was asked to come in as a expert on a accident investigation, because someone had received an electric shock, and we found the cause to be neutral was being switched rather than live. So when he'd isolated it, we still had some voltage, and he didn't pick that up and got a shock. So leaving an area safe. So if we need to leave our isolation, we're finished for the day or going to do something else or whatever, but we're going to leave the isolation in there, so we haven't finished that work. There's a couple of things we need to do to make sure it remains safe. So we tape up the cable ends or use a strip connector, so any exposed copper in our cables is tidied up and no one can accidentally come in contact with that. It shouldn't matter if nobody switches it back on, but it's always better to be safe. Cables are protected against damage by tucking them away, so we don't leave cables hanging out of the walls and over floors and stuff like that. That's good for protecting the cables, but also people. We don't want people to trip over our random cables everywhere. and that the danger tag is replaced with an out of service tag, so everyone knows they're not going to switch that off. All right, so some additional notes for the disconnection procedure. There are a number of methods of isolation here. So we've got an isolating switch, which we talked about, a fuse or a circuit breaker, which are both in the switchboard. But removal of load phase wire or wires at the switchboard. So that's where I would, as I said before, you get the circuit breaker and you physically disconnect the wire out of the top of it so it cannot be turned back on. It says there's special circumstances, i.e. longer term. Yeah, you might do something like that where you are permanently removing something from, let's say you're taking out a hardwired compressor. We don't need to leave that circuit live, so we'd probably go back to the switchboard and physically disconnect that cable out of the switchboard. We must ensure that the correct fuses are pulled, and in the case of a three-phase appliance, 3 fuses must be pulled. So usually with a three-phase circuit breaker, it'll be one switch will disconnect all 3 phases. But if it's protected by fuses, then we're going to have 1 fuse for each phase, and in that case we need to make sure we get all 3 of those fuses. It's usually fairly straightforward that the 3 fuses will be together for each specific circuit. So it's not like 3 random fuses located around the switchboard. Isolation must be foolproof in the sense that it must be impossible for someone to reliven the circuit while work is taking place. Take steps to ensure the power cannot be restored while you are disconnecting the appliance. Remove the fuse completely, or on circuit breakers attach a lock where possible. Ensure tagging procedures are properly carried out, so danger tags and so forth. Yeah, so we've discussed at length about locking circuit breakers. In the case of fuses, there's a couple of ways that we could do that. My preferred method would be to remove the fuse from the fuse holder and put those fuses in my pocket. So I've got them on me. Nobody else can come and reconnect those fuses or plug them back in because I've got them with me. So we need to make sure there's no possibility of any exposed or readily accessible wires or terminals becoming alive at any time while the equipment is away for repair, or if any disused wiring becomes alive. Danger can arise to the electrician or others from relivening of the disconnected circuit wiring. So if we're taking away an appliance to get repaired, or we're removing something that has been that needs to be taken away, then we need to make sure that we're not leaving the ends of the wires, remaining exposed because somebody else could come along and reliven that, or we might reliven it before we go, so that everything else on that circuit's operating again. So we need to make sure that we make safe those circuits, make sure that nobody else can come in contact with the wires. The wrong way, there we go. We should attach an out of service tag if reconnection is not immediate. So if I'm not finishing the job that day, we must have an out of service tag. Ensure other critical circuitry is not left out of action. So if I've disconnected something and I'm removing it and there's other things on that same circuit, I'm going to need to make sure that what I've done is insulated, and I've got to turn the power back on for that circuit because there could be other things on there. Ensure labeling of conductors is correct, ready for reconnection. Now this is an interesting one because throughout most of my career in the electrical trades, labeling things and taking notes was really, really important. So if you disconnect anything, if you're just disconnecting phase, neutral and earth, it's pretty obvious how they go back. But sometimes there's lots of different things going on, switch wires and non-switch wires and so forth. So I would always take notes and put labels. A great way to make makeshift labels is just have a roll of white insulation tape. You scribble on there what each wire is, and you tape it. Put that bit of tape onto the cable itself, which is cool. These days, things are a bit different because you can just take a photo. So take a photo before you disconnect anything, and then when you come back to do the reconnection, just have a look at the photo and you can see what it looked like before you fiddled with anything. I think that's probably a better way, right? And most of the time, like I say, doing notes and labels is great, but because I've always been quite absent-minded, I would often not do that, and for some reason in my head I would always think, I just have a look. I know how it's reconnected. That should be fine. And then maybe an hour, 2 hours later, or perhaps a week later, you might be coming back to it and you go, oh, shit, I forgot. So taking a photo is a great idea. Otherwise, take notes and make sure you label things. Motor rotation. Direction should be checked and appropriate notes made. If practical, this may involve running the motor before it's isolated. Obviously, it's not feasible if it's burnt out. Yeah. So generally, a motor is going to have a direction that it needs to turn. If it's connected to a piece of machinery, then that motor can only operate in one direction. So if that's critical, then we need to check which way does the motor turn before I disconnect that motor and take it away, because when I put a new one back in or a repaired one back in, or maybe I'm reconnecting the same one, I need to make sure the motor's going to be turning in the same direction as it was before. So our reconnection procedure is essentially the reverse of our disconnection. So first we talk to the person on site who's in charge, and we identify the circuit again. It should be the same one, but if you've left the site, go through that process of checking again, because you don't know what's happened while you weren't there. Ensure the circuit is still effectively isolated. So if we left it isolated, then we just test it again using the prove, test, prove method. If we turned that circuit back on, if we relivened it when we finished previously, then we're obviously going to have to turn it off again. Once we're finished, we remove once we've done the isolation, we take the outer service tag off that we left there when we went away, and we put a danger tag back on, because remember, the danger tag tells people that I'm currently working on this. When the equipment is reconnected, ensure there are no missing strands at the connection point or any loose connections. Re-terminate any damaged wire ends and fit new lugs if possible, if required. Look, that's just good work practices, right? So make sure all our connections are good, make sure they're tight, make sure there's no little bits of copper flying around, make sure we haven't stripped it too long and there's bits of copper hanging out of the terminal. As we go through the course and do more wiring tasks, you'll get much better at that and understand what a good connection looks like. We need to do an insulation resistance test, and normally the reading should be less than 1 mega ohm, so 1 million ohms. Until we get more into some of the specialist testing, the relevance of insulation testing perhaps won't mean much to you, but we're just testing that there's no leakage between one conductor and another, which I have talked about before. When it says normally less than 1 mega ohm, we do have situations where it might be less, particularly with water heating appliances, so hot water cylinders and stuff like that. You can get readings that are less than 1 mega ohm. So in that case, with a water heating appliance, the minimum reading is 10,000. We should do an earth continuity test on the equipment that we've reconnected, or the new equipment that we're installing. So that means that the earth wire from the wall is continuous to the body of my appliance, and it should be less than 1 ohm. Well, it must be less than 1 ohm, not should, must. Switch on the circuit breaker, so we turn the power back on. Obviously we unlock it first. We do our operation test. We make sure that the equipment is now working, because I promise you will feel like a dork if you switch everything back on and then walk off, and the customer rings you later and says that thing is not working. And then we take away any of our tags and we're done. So a couple of additional notes here. Methods of isolation, same as we talked about before. Isolation must be foolproof. That means that we physically lock it out in some way to prevent that from being re-enabled, just like we talked before. And as we said on the last one, make sure that our reconnections are done properly, that all of our physical wire connections are good. The safety tag system. The electricity safety regulations 106 states that safety tags or personal locks must be used if there is a danger of accidental livening after the isolation of an appliance or part of an electrical installation. So that means in the law it says that we must lock and tag our isolations once we've done them. For added safety of a lockout facility, for example, a lockable isolator, for added safety, a lockout facility should be incorporated in the system. If so, it must be used. So that means if we're doing new circuits, something that's going to, particularly with something that's fixed wired, we should have some sort of switch there, a lockable switch, and if it is there, then we should use that. It's better than isolating it back at the circuit breaker. The tag would then complement the lockout device, typically at the switchboard. So again, wherever we've locked that out, we must attach a tag to let everyone know that we have locked it out on purpose, and then not to touch it. Remember, of course, that if somebody, when people accidentally turn things on when you're working on them, it's not usually malicious. Well, it's never malicious. They do it by accident because they see that it's switched off and, oh, my circuit's not working. What's happened here? Oh, there's a circuit breaker off. I'll switch that back on. So that's why we have to have those tags. That's why we must have locks. And it's happened to me once before where I didn't lock something out, and somebody came in and switched that circuit on. Fortunately, I didn't get a shock, but I could have, because they switched it on because I had not locked and tagged it. Safety tags or labels, although employed extensively overseas in overseas countries, are not used in New Zealand to the extent that they should be. The purpose is to ensure the highest standard of safety amongst those persons who operate, service or repair machines and their associated power supplies and control systems. So yeah, the inference there is clear. I think it's getting better, but certainly, I mean, even 10 years ago when I was working on the tools, doing lockouts was kind of seen as a bit sissy. That you know, what are you afraid of? I think nowadays it's a little bit more used extensively. And just a point here that I'll mention, and we'll talk about this on our next conference call, but we just need to be aware as well that we might not always be two things. We might not always be isolating and doing an electrical isolation just because we're doing electrical repairs. I mean, think of a giant sausage grinder at a meat factory or something. If somebody needed to get in there, maybe to clean it or service it, we're probably going to do an electrical isolation on that at the same time, right? Otherwise, if it turns on while they're in there, they'll get turned into sausages. We don't want anybody turned into sausages. Human sausages are horrible. So we may be asked to do that kind of isolation and tag out for something like that, even though we might not be working on it. And then the second one is that you may also need to isolate and lock out stuff that is not electrical. A good example of that is in my previous experience in the fuel industry. If we were doing work on the fuel part of a dispenser or anything on the site, we would do an electrical isolation for any motors and stuff like that, so they're not going to start and pump fuel. But at the same time, we would have valves on the fuel lines, and you would turn those off and lock them as well, because that prevents any fuel being pushed out through the line while you've got the line open, right? And you might see that in pneumatic systems with compressed air. They might have lockable valves. Any gas or oil pipeline type system will often have lockable valves. Even water. So if we're doing something where there's a lot of water or high pressure water, you might want to turn off a valve and lock it out, and you'll often find lockable valves on stuff like that. So it's important that if we've got different types of energy, not just electrical energy, fluids or gases under pressure is the common one, that we lock out those types of energy as well. Okay, so the important aspect of the tag system is that any person may apply a tag, and it can be applied to all plant and equipment, and it must be complied with by all persons. So anyone can put a tag on something. We've again talked about before, we might have multiple people working on something, and as I said on the last slide, it might not always be electrical. So I might tag something out because I'm doing electrical work on it, but then one of the mechanical guys might tag that same thing out because he's doing mechanical work, and we don't want that turned back on until both of us are finished. So anyone might apply a tag. And the bottom one there, it must be complied with by all persons. Yeah, the last thing we want is some random people running around thinking that they can do whatever they want. Everyone has to comply with the same system, otherwise there's no trust in the system. It doesn't work. So here's an example about danger tags. They read danger. It's a danger tag. It says danger on it. That's how you know it's a danger tag. They're used if there's a job that needs to be done, and if there's a possibility of personal danger through somebody turning on the electricity, or a faulty machine, or a flow of steam, gas or liquid. then a danger tag must be fastened to the appropriate isolating switch or valve or control. So this just reiterates a little bit what I just said about making sure that we isolate other sources of supply as well, not just the electrical energy, anything else. Couple of points to watch. Make sure that the switch, valve, control or piece of equipment is the correct one to lock or tag. If there are any doubts, ask the supervisor or person in charge. Make sure the switch or control is in the correct non-dangerous position when locked and tagged. Yeah, the last thing we want to do is accidentally lock something on rather than off, although you will find that most lockable isolators and valves, you can only lock them when they're off. You can't lock them on. Test before touch. So test before touch means, in addition to our prove, test, prove, sometimes we'll just do a quick test. If I've isolated a whole machine and I've tested that the supply to that machine is off, every now and then I might just, if I move from one part of the machine to another, just do another test before touch, just to make sure that there's nothing else going on. There isn't a second source of supply coming in or something like that. So test before touch is an important one as well. An isolating switch is one that can be locked in the off position. So some switches are not positive isolating switches. Switches such as a push button type or an emergency stop or switch, a master control and control switches in pulpits and on control stations are not and cannot be used as isolating switches. Okay, so there's a little bit to unpack there, and this might be something I talk a little bit more with on the conference call, but if we think about an emergency stop system, an emergency stop system such as we would see in our classrooms can switch off the power to all of our sockets, but we wouldn't use that emergency stop as an isolator because someone could turn it back on. I can't lock out every emergency stop switch, so on and so forth. And actually different emergency stop systems might work in different ways. So although I might turn an emergency stop off or even isolate the power to the emergency system, I may still find that there's power on other parts of the circuit that I wasn't aware of. So we should never use any sort of remote control or remote isolating switch or emergency stop or something like that as our isolator, either by switching it off or cutting power to that system and assuming that it's cut power to everything else. If I go into any more detail than that, then with the amount of experience and knowledge that we have now, it probably won't make any sense. So you just need to be aware that we don't isolate control systems and we don't isolate emergency stop systems as isolations for main circuits. I think that just about covers it. There is a question about that in the test, so we'll cover that. We'll talk a little bit more about it when I'm actually talking to all of you. We need to fasten our danger tag securely so it doesn't fall off. That should be obvious. We've got two people working on the same job. We must each have our own tag and lock. We've seen before that you can have multi-lock, so we put that lockout device on the isolator or circuit breaker, and then multiple people can have their own locks and tags, and we should do that. Every single person must have their own lock and tag, so we can't accidentally liven something while there's still someone working on it. We all have to take off our own individual locks before that can be relivened. The supervisor or person in charge will investigate the work area and fasten his own danger tag to any point that, if operated, would be dangerous to persons or machines. So supervisor might also put a danger tag on even if they're not working on it themselves, and then in that case they would probably be the last person to take their tag off. The supervisor or person in charge would then be responsible for seeing that all people have removed their tags and are safe before they remove their tag. So as I just said, they would be the last one taking the tag off. Removal of danger tags. When the job is finished or work is stopped at the end of the shift, each worker must remove their danger tag. However, if it could be dangerous or could damage machinery when somebody operated the switch or valve, an out of service tag must be fastened to it. The person in charge of this or their deputy must be informed of the situation before leaving the premises. Yeah, that's it sounds very formal. It's probably an informal thing. You just let somebody know on site, I've still got this tagged out, it's still switched off. If you don't swap your danger tag for an out of service tag, it's not the end of the world. As long as we've got a lock on there and we've got some sort of tag, that's the most important thing. So having a look at our out of service tags, so these ones are yellow and black. They list equipment or machinery out of action for repairs. and prevent damage to plant that would happen if somebody used the switch or valve, etc. So this might not be personal danger, but if I've left the machine in bits and somebody switches it back on and bits are going to go flying everywhere and destroy that machine, I need to have an out of service tag. Machinery or equipment with an out of service tag fixed to it must not be turned on without the direct permission of the supervisor or person in charge. And then it makes sense then that wherever I attach that out of service tag must be where somebody would go and turn it on. There's no point in me attaching a service tag somewhere else and then somebody could come and switch that thing on without seeing my tag. What have we got there? That is the same information that is on the last slide, so we'll skip that one. Removal of out of service tags. Never remove an out of service tag unless the supervisor or person in charge has been informed and the equipment involved has been cleared for safe operation. In most cases it would just be you anyway by yourself, but it is what it is. Remove only after it is safe to do so and that all the checks and tests have been made and the equipment is ready to be started. Yeah, remember that once you remove that isolation and remove the tag, that anyone can come along and switch that on at any time. So we definitely don't take that off until we are absolutely ready to turn that on, and that nothing unsafe is going to happen if we do turn it on. Alright, that is the end of that one. Okay, so there's a couple of little points that I will bring up in our conference call, just because the test has got a couple of little extra things that won't, they were briefly covered here but not covered in detail, so you need a little bit more information. Other than that, that's it for this one. Got through that pretty quick. Well done. Cheers.